Hello there, ICS2O folks. Today's lesson is on our fourth stage of the SDLC, testing and documentation. And you're kind of getting the picture that this process is probably for bigger projects that, out in the real world, but we will get to do a little bit of this stuff, and we'll take some of the knowledge forward in our programs as well. We'll see by the end there'll be some exercises for you to do. I have made this fancy dancy Google Slides presentation. It's not that fancy. If you want to do this in a regular word processing document or smart notebook, whatever you like, you go right ahead. That's fine. There's the title. And it's a little bit of writing, but I'll remember you can pause. You can pause me. Testing and documentation. The testing and documentation phase begins as the code is developed in the implementation phase. Remember, code is tested in small chunks as it is written, and comments, also called internal documentation, are added to the code by the programmer. This is standard programming practice. So the idea is in implementation, we are already doing some testing and documentation. The phases overlap, and that was kind of one of the criticisms of the waterfall method of the systems development lifecycle, is that some of these things overlap and are done at the same time, and certainly testing and documentation is done at the same time as implementation or code writing. However, the testing phase refers to a more planned and systematic test of the program. There are many different types of testing, but for our course, we will consider just two: Whitebox testing and Blackbox testing, and I'll explain the difference between those two soon. The idea is the formal testing phase happens after the code is done. The programmer thinks the software is all ready to go, and now they're going to start putting it through the ringer, and the ringer is this testing phase. So Whitebox testing. Whitebox testing is referred to because you can see it. When it's white, you can sort of see in it. It's also called glass box testing sometimes. It's programmers familiar with the code conduct thorough and planned investigation of the software after the initial coding has been completed. Test cases are developed to test all possible execution paths of the software. So a test case is to pick values of the variable beforehand, predict what the results in the program are going to be, and then run the program and see if you were right. Okay, or that's a way to check for bugs. And as bugs are found and fixed, the testing process must begin again to ensure the new code had no unintended side effects. So you've already had experience of this in your programs, is you get an error somewhere or a logic error, and then you fix it and it causes a problem somewhere else. Well, you can imagine when you have a huge piece of software that you're trying to develop and you fix one little thing, that it might have unintended side effects elsewhere. And so this testing and coding phase is very, very repetitive. It's cyclical. So you fix a bug, then you got to go back to square one as far as the testing is concerned. It's called white box or glass box because you see into the code and you predict how the code's going to behave. For us, I'll show you what this is going to entail. We sort of did a little bit of this when we were reflecting on our own code, but this is what it'll mean for us. I'm going to ask you to fill out this white box testing sheet. This is by the programmer of their own code. And so this idea is you answer these questions honestly. What assumptions about the user do I make in order for the program to work properly? So for instance, when you ask for an integer, do you assume that they're going to be able to type in, the user will type in an integer, or are you going to handle if they can't? Well, at this moment in time, we can't deal with it. We have to trust that the user will follow instructions and put in an integer instead of a decimal number. And so in your program, you'd list all these places where you kind of have to trust the user. Have I controlled or idiot-proofed the user's input in any way? So if you're expecting them to enter a mark, say, and they put in negative 812, are you checking for that? There should be some cases that aren't allowed, and you can loop until the person um, puts in data that makes sense. Similarly, have I formatted numeric and text output appropriately? Some of you are getting feedback about that on your programs, that you need to control your output. Your output is as appealing and attractive, and this is all you reflecting on your own code. And in filling this out, I'm hoping that you'll catch errors, fix them up before you hand in your programs. Aside from the assumptions made in question 2, does my program work for all possible user input? Fill in the testing table below. So you'd pick a variable and then the value, and then you predict the result. So for instance, if you're expecting a mark and they put in negative 25, so this is the variable would be mark, the value would be negative 25, what would you expect it to do? Would you expect the computer to give an error message? And what does the program actually do? So this is these 3 columns are filled out before you press run. It's almost like you pick values of certain variables and you predict what the output will be, and then you run the code after. Okay? This is kind of our version of the test cases. Each one of these lines is kind of like a test case. In big software packages, it's a bigger story, but we're not too worried about that. Lastly, does my program terminate appropriately and when expected? I hope someone else is going to get the phone because I'm in the middle of this video with you folks. So hopefully somebody will get the phone. Back to the lesson. Whitebox testing we just talked about. So in contrast, there is black box testing. And black box testing is called that because it's a user, and it's sometimes the customer gets to goof around with this. Test the program for functionality. Does the program work the way it's supposed to? And it's called a black box because you don't see into the code. You're just using the program itself. And is it easy to use? Is there, does the user understand what's expected? Beta testing, and you've heard that phrase, I think, a beta testing is a type of black box testing. If you were involved in the CEMC Python stuff, that is black box testing. And for us, again, let me show you the sorts of things that you're going to be asked to do. Black box testing, we did a little bit of this when we were reflecting on a peer's code, but this is more specific. You're going to fill out this page, honestly, and I think I'll have copies of this that you can actually type into. This is a PDF, but I'll have copies that you can actually type into. And then circle or highlight or bold this so you can communicate back to the user about problems that you had when you were using them without actually looking into the code. Okay, that's black box testing. Back to the presentation. Only a couple more slides. You don't have to include these pictures. I should have told you that earlier, but this is kind of a nice picture to show you. You can't see the code. Here you can see this is the algorithm flowchart thing. You don't have to include these pictures if you don't want to. Documentation. Documentation for our course usually starts and ends with in-code documentation. Comments, meaningful variable names, appropriate white space. I've been bugging you about that kind of documentation early and often. But most large-scale software packages have external documentation, which can take several forms. You could have a README file that's included with the program that includes instructions on how to install and use the software. And in fact, we're going to take a crack at that. We're actually going to try that this chapter. Or we could have an in-program help file that gives the user guidance about how to use the software. So for instance, in big ones, there's always somewhere that you can press help. Well, that's documentation that you'd think it's internal because it's inside the software. This is inside Google, but really that's something that was done separately of the code. Okay, so it's still external documentation. The last thing is you could have a manual, like a textbook that we have, or we've got some online manuals that are separate that you'd look up answers. Okay, and that's external documentation too, about installation, use, troubleshooting, etc. Okay, I think you've got a couple little things to do, exercises to do with the three-phase, and now the three-phase program that you've been working on this week, and now here's the fourth phase, which is testing and documentation. So have fun with that exercise, folks. That's it.